We start now. Okay. Hello. Good afternoon. My name is Carlos, and I am here today to make a little overview about what you can find on Einstein Analytics and what are some of the topics that you would need to study and prepare for the Einstein Analytics and Discovery Consultant. Uh, how do you say certification. Sorry about that. So let's start. I will show my screen now. So um, let's start with it. So Einstein Analytics is a platform for making deep analysis on data on your business and organizations. And on top of that, Salesforce adds some features that allows to make some machine learning and prediction models on your data to better um give recommendations on what to do next on with your information. So when you are doing your certification exam, it is composed of these topics. You have the data layer questions, security, administration, dashboard design, dashboard implementation, and story design. And I will give some commentaries along on each of those topics. First, on the data layer, the Einstein Analytics have a separate platform for managing data that is not directly accessible through the normal Salesforce data storage. So in order to run the dashboards and other transformations, you need to have the data inside the Einstein Analytics platform, as you can see on this graphic. You can import data into the Salesforce Analytics, into the Einstein Analytics platform into two ways or three ways, I believe. You can have the data sources that are internal from Salesforce, where you can have manual or automated synchronization jobs that take data from your Salesforce objects, like cases, opportunities, accounts, contacts, etc. You can add connectors to external services like Amazon Web Services, um, Heroku, and others. You can add connections to uh, the database connections like SQL Server, Oracle, SAP HANA, and others. And you can also add other data sources from local files like CSV files, Excel files, and you can use both all of those data sources as to create local data sets inside Einstein Analytics. And after that, you can use two types of transformations to prepare your data for analytics. You can have recipes. Wait, you can have recipes and data flows. Recipes and data flows are both transformation tools that Salesforce provide for us that allows us to make changes to our data to clean up invalid rows, uh, fill up empty fields, and other things, so that we can make sure that our charts and graphs have something that is cleaner, and to make sure that our models don't have many clutter inside the data to prevent the models from uh, make some predictions that are not correct. The data sets are the basic building blocks of Einstein Analytics, and they have three basic data types only. You have measures that would be any type of data that is numeric in nature. Like you can have a currencies, you can have measurements in meters, kilometers, miles. You can have numbers of um, of subscribers, um, that sort of things. Then you can have dimensions. Dimensions is a general um, concept that is related to how you label your records. You can have, for example, you can have a company that has, let's say, cable TV company that have subscribers, and your subscribers can be divided in regions. Then you can use a dimension field on your dataset to label the borough, the city, the state where your consumers are. So they are treated like dimensions. So they are simple labels that you can only group them, but you cannot make additional operation like adding, subtracting, and other stuff. And then you have the date fields. Um, on particular, uh, you have both recipes and data flows. They have some limitations and some um, strong points on that. And when you are working with recipes, you have like a more iterative tool to manage your transformation. So you can import your data, and you can see on the fly while you are making tweaks to the type of transformations, to while you select what fields are you importing, what types you want them to be, if you want to make some cleanup. So you can make some previews on the fly, and so it is the feedback is much more instant. One limitation it has regarding to the data flows is that recipes can only create one data set. You can choose many inputs, two, three, or four data sets from input, but you can have only one data set as output. So that is a limitation. Um, and when you're doing the cleaning and transformation, you have many controls that are much more specialized and much more easier to use on the user interface. This kind of transformation is much more oriented to administrators and people that don't have that much technical depth. When you're working with data flows, you can create and update multiple data sets at the time. So you can have you have more flexibility on how you manage your data. You can have only one data set from input, and from that you can make many complex operations and create two or three different data sets, or update two or three data sets, or and you can also do the same thing that we did on with the recipes that have only one data set as output. Um, much much of the much of the transformations you are working with on the data flows, they are usually done using SAQL queries that are defined inside the nodes on the data flow itself. I will change my screen to show you one example of here. This is a data flow for a super batch that I did a few months ago. Here you can see some of how the data moves from one node to another. Each of these nodes makes some changes to the data that is being handled. Each row that passes through them, it makes something else. So in this case, you have this node that is called edgemart, the type edgemart. It will um, load information from a dataset that in this case is the seed chart dataset. So the only thing it does is it just reads the information from the dataset row by row and passes that row to the next node. Then you can have um, some nodes like this compute expression that what it will do is it will uh, make take each row and make some computation on it. In this case, as you can see on the chart, you have all these fields that are here. Those are fields that are referenced from the previous node. As you can see, the node name is node load seed chart, and that is just the output field. And you can have you can see here this node it adds um, another field that is called acreage. So it creates a new field. And when you see the details for that field, it takes then some fields of the input and it makes an operation, and that creates a new value. So those are all compute expression fields. This one is special. This type is augment a node. What it will do is use two different sources. In this case, we have rows from a different data set that is, in this case, is temperature classes mapping. Uh, that is a data set that we are not modifying the rows itself by until yet. And this other one, the seed chart field, that's it. Then we are making sure that we have rows that merge um, information from both record sets, and pass them as only one field, as only one row. Then you can see here what it will show us output. One thing that you can see on this is that you are not it's not mandatory to output all the fields of the that you are getting from the input into the output. You can use some of those. You can discard some of those fields if you believe that you don't need them. So you see here the list of the fields with the column names. What this one slice data set. What this one does is it will filter out field records that we don't want. Uh, in this case, let's see. Oh, here. No, I did make a mistake here. In this case, the slice data set it does the complementary part of the what I explained on the other step, where this will remove columns from your rows. You have the mode to keep or to drop the columns, So in this case, it will eliminate those columns from each row that is passed along. And this one is the register that this will create a new dataset. So you can uh, set up the name of the dataset here, and it will create a new dataset that's called seed bank. If you go here on the data manager, you see here that there is a dataset that's called seed bank. This one is created by running that data flow. So this is a simple overview of what a data flow is. I will now change back to my presentation. Uh, Another thing that is important is that when you are working with those datasets, uh, sometimes data, most of the times, I mean, you are consuming data that is present from other systems. So your dashboards, your predictions, they rely on data, but you cannot access them on real time. So you need to have some jobs to import those data into Einstein Analytics, and those will be the sync jobs. Synchronization jobs would have three basic modes. You have the uh, full sync mode, that is the where you replace all the records inside your dataset with what you take from the origin. That is the mode that you will always run the first time you are creating your datasets. After that, you can have the incremental sync mode, where you will only update records that have been added or modified on your source. So Einstein Analytics has a way to know if some data has been changed on the origin when you are working with Salesforce data. So it will not change all the rows from your data set. And you have this one that's called periodic full sync. This one was added, I believe, this year. Is a new feature where uh, you will have uh, normally you will do incremental syncs, but every time, like I believe, like a month or 3 months, you may have some full synchronization mode when you are doing your synchronization job. This is important because you you want to make sure that your data is up to date, and you can have that with full sync, but full sync usually consumes a lot more resources on the platform, and that can eat up the limits the platform gives you for synchronization for each day. So you don't want to do always full sync, but you don't want to make incremental sync as well, only because there is the synchronization is not perfect, and it will have some difference between your actual data and the data in analytics, because there are two cases where analytics does not work well on incremental data. Those two types are when you are permanently deleting records on your source, like you remove a contact from Salesforce, then all the rows related to that contact will not be deleted from your analytics if you do incremental synchronization. And the other one is for um, formula fields. So fields that are derived from calculations from other fields are not updated correctly with incremental synchronization. So you sometimes need to do the full synchronization. Uh, on security, uh, you have the elements in Einstein Analytics. They are grouped into something that's called an app. I will show you what an app is here. Uh, an app is a collection of you can have dashboards, stories, lenses, and data sets. So um, all the things that you need to run components inside Einstein Analytics, they are grouped inside those applications, those apps. Wait, sorry about that. So there are three types of permission levels that you can have for those applications. Those are the viewer, the editor, and the manager. With the when a user have the viewer permission, they can see the application, they can see the dashboards, they can even interact with the dashboards, but they cannot make changes to the dashboard, to the data set, to the lenses, and to the stories. With editor, you have some more permission, so you can create dashboards, you can create charts inside the dashboards, you can change colors, you can change text, you can change formulas. And with manager, you can also have the options to grant or remove access to the application for other users. um, on on that note, you every time you create an analytics user, you will have two types, two special types of applications. There is one that's called shared app. That is an application that has components that are available by default to all users. Everyone can see what is on the shared app. Um, the administrator can add or remove permissions for that application, but by default, out of the box, this one is available for everyone to see. And every user has an independent My Private app that is only available to that user. One thing that is interesting about the My Private app is that this application you can have data sets, dashboards, and other stuff that are not visible for anyone else unless you specifically give the permission, even other administrators. So you can have something that not even administrators can see if you don't give access to them. Um, Apart from those, you can have other applications that will by default be private for the owner, and but also the administrators have access to have manager access to it. So you can be a normal user, and an administrator can make changes to your application if it's not in the My Private app. One thing that is important is that on security is that you can have the data sets and dashboards be living in different applications. So you can have an application A and an application B. One has two or three data sets on A, and on B we will have the dashboard. And you can have the dashboard on B using the data sets that are present on dashboard A. Uh, but in order to run that dashboard in B, the user needs to have the view access for both the application A and B. So you can you can make some changes to the access levels of different of different applications to change the visibility of what is accessible to other users without giving access to the full application to someone. Also, when you are giving access or revoking access to users to those applications, you can make those grant those access at the user role and group levels. So on Einstein Analytics, you have some uh, set of transformations and to modify your data and charts to visualize that data for the users. And you can group those in dashboards to make them uh, more conveniently designed. Um, the dashboards, they can be designed to work both from desktop and mobile devices. And as I mentioned before, you can interact with the dashboard. You can click on a column on a bar, and you can see what is particular for that variable. I will make I will show an example of that here. Uh, Here I have this dashboard that I create on another project. When you see here, you can wait. I am on edit mode here. This is the dashboard on the interactive mode where the normal user would see. You can make clicks on the on different controls, and some of them, like this one, it will apply filters to the dashboard. Then it will change what data is being used to make the calculations. Like this one, you see, you click this filter for medium risk subscribers, then it changes two two controls. You can also make changes to this one where I am filtering for, in this case, this this chart was the name of a modern manufacturers. And then here you can see the what are the qualifications CSIT of the consumers that have this type of modem device. And this is the in this case it was this dashboard is an average time of tenure where the user is subscribed to the services from the company. So you can see what is the average time the user uh, keeps subscribing to the company depending on what device you are giving it to them. So you can change the filter, then it will show different cities with different scores and different average times. So this is very interactive. You don't need to see if you are interested in one particular region, then you can also change here. Like this one is sorted by this one is shows the totals for subscription for each city. Then if you click on the city, it will also filter out, like you see here. And you can click back to reset the filters back. So this is what is interesting about those dashboards, is that you are not showing some static information, but instead you are showing some information that the user can interact and go deeper if they are interested in something in particular. Okay. Um, I put aquí a list some types of charts that are most used. You have those bar stacks, pies, maps. There are some also um, scatter plots and many other ones. Uh, this one is important when you're working with dashboards because since Einstein Analytics doesn't have as many years of implementation, there are some things that are not fully implemented on the interface level, but the Salesforce allows us to modify the underlying representation of the dashboard itself. Uh, then you can see here if you use this combination of keys when you're on edit mode, you can see the representation of the dashboard itself. I will show here. When you go on edit mode, you click Command E on Mac. Then it has a JSON representation of every component that is present on that screen, from the lenses to the charts themselves, colors that you are using, everything else. You have the including queries that are being executed to generate that data. One particular case where this was important when I was doing this particular super batch was with this control in particular, because there are some things inside those dashboards that are called bindings, where you can use you can use the data sets themselves or some queries to use as source to generate the data that is displayed on the chart. And sometimes you want to also use what is selected on other controls, like on in this case this control in particular was used to filter out the input for this one. But the the um, the um, the control to make this thing happen is not fully implemented on Einstein Analytics, but you can do it from below from the JSON representation. And I believe, wait a moment. I believe if I look into this, so this was one particular case where I have this binding here that I cannot add this with point and click on inside the application. So if I wanted to add this to my dashboard and make it work properly, I had to add it with code. I believe that in each season, the people working on Einstein Analytics are working better to cover more of those cases. So eventually, I believe that we will have a point and click or something more beautiful to add this type of bindings into our controls. But that's what we have today, and it's important for people that will be working with Einstein Analytics to know about this. Okay. Dashboard design. Uh, about the design itself, Salesforce has representations, some representations that some criteria that you need to take into account when you are designing your components. Uh, Mostly, you will see recommendations about what types of charts you will use to represent certain type of data, what colors you will use to have a better contrast of your data and your background, what position you are putting your chart so that you have information that is more relevant for general people at the top, and information that is more specific at the bottom. Like you will have in sometimes you have a line or a bar chart at the top, and you can have a table view at the bottom with uh, the actual data that is used to create that bar chart. So you will try to make sure that when the user uh, opens your dashboard, the first thing it sees, it should be something that it catches the eye of the user, so it gets engaged into seeing that this information is interesting for me. I want to know more about it. So uh, and this is those type of criteria is somewhat subjective, something that is not is a little bit harder for people that have developer background like me. We use are used to work more with code and testing and other stuff, but this type of things is something that we need to have some concept of it, and is something that will be questioned in the certification itself. So, and for the last part, I will talk about a little bit about story design. This is not about design on the visual sense, but on design on the how do you uh, how do you talk with your data? How do you read what it says and how do you interpret it? So when you are working with stories, there are three main sections that you can see here. Uh, you can see what happened, why it happened, and what could happen. Um, when you're working with a story, you normally will use a data set as input, and you will want to select a variable that you want to maximize. In the case of this screenshot that I took from my org here, let's see. This story in particular is predicted tenure, is based on what the application read from the previous data from the previous years of your subscriptors, and what the characteristics that you provided the application. It will try to make a sense on what is that happen with your customers. Where are the more where you have more clients, where your clients have a higher or lower turnout, uh, and it will try to use additional information that you provide them. I believe that on stories you can use up to 13 columns of information as input that you will try to make correlations to the output, that in this case is tenure. So in this example you can see here, uh, it says that modem age explains 33% of the variation on tenure. So you can see here that the new modems, it will at an average, it will increase above the average time the consumer your clients will be with you. In the graph here, you see an average of 13. That's 13 months. That's the average time your client subscribes to your service, and then 13 months later it will drop out because of some reason. Modern age is one of the reasons where you see that if you subscribe your client with a new modem, the average will go up to 18 months. If your modem is less than 1 year old, you they will go on average 16 months. And if it's 1 or 2 years old, your modem, the age of your modem, then 14 months. And you see that on other that will cover all other ranges of ages from the devices. So you see 3.5 months for other clients that kept all their modems. So this is one explanation of how a modem age affects how much time the client stays with you. So this is one insight that's important that the application took from the data. You can see other ones here. You can have a correlation that it will find for more than one variable, like this one, where make correlations with modern age and for all the clients that are only on Rhode Islands. Like it will group records that are only for one label in particular, and compare with the other regions here. So it is the same classification, but also making distinction with this region versus anyone else. So this is what, and when you are looking at this, you normally will need someone that has some knowledge of the domain of the data that is being presented. This is very important because you need to know something of the business to make sense of those correlations. Because you will find on these predictions some correlations that that makes no sense for you if you don't know anything about the business. But if you know something about the business, then you can make some sense of it and make some decisions about it later. Uh, the other uh, the other part of the story is why it happened. This one is interesting as well because when Einstein Analytics studies and make models about your data, it will try to have some weight on how much one variable affects your total outcome. As you can see here, the global means it says 14, and then it says that modern age modern age is other. That means that it has more than 2 years. So if you as you can see here on this chart, when the modern year the time the modem has been working is longer, then it takes a lot of the average time the client will stay with the company. So this is one thing that is important. You see that modern age is other and contract is month to month. So for those clients that are on older models but are still paying on a month to month basis, it they stay a little bit longer that compared to those that has an annual or biannual contract. So those that are reaching, like, for example, those that are reaching the end of a year contract and are using a modem that is older, they are a little bit less likely to stay with you if they will have to sign another 1 year contract with you. So this one interpretation you can find from this one. And this one is like take another comparison with electronic check and others and another thing. So every bar here, it will try to tell a story to you of why why things have changed in some ways. And with those correlations that the application will find, then you can have some new insight that you could not find just by looking at the raw data. One thing that is important when you're looking at this why it happened, they will always have one one last bar here that is called unexplained, that the model trained with your data, and it created some correlations that it thinks it will it explains why the variables changed from one client to another, and there will always be a gap in the difference of what it trained and what it actually measured, and that difference will be the unexplained. On a model that is very well trained, those unexpected differences will be should be lower. If your unexplained difference is a very long bar, then your model is not catching correctly what is going on. So you should take that into account when you're looking to why it happened. Uh, and as you can see, this is one example of why it happened. The Einstein Analytics, what it would do is it would permutate between different combinations of values from your columns, and it, using fixing one value in particular, it will try to make some simulations to try to explain how that how making something fix affects the other things. So you can see that a modern age this is what explains the difference for when modern age is less than 1 year. So you can see what was measured at the end of the uh, uh, with your data itself, the on average of 16 months. And you can see here that on this case, your unexplained factor on those is very low, so it you can almost not see the bar here. And if you want to see why the for the clients that are less than with more than that, with less than a year, why they behaved how they behaved, then you can see that uh, this is modern age is less than 1 year. This by itself has a negative impact in general, but if you add by region, yeah, those are all by region. And this one is particularly interesting. This one is small terms related. Small terms, I believe, was a column that was related to contracts. That's something that you would need to look into the data to see what are the columns, what they mean. But well, as you can see, those big bars here, they say something that you need to look into. So you can use this to gain some insight, and with that and the expertise of the person, you can you can have some you can make some business decisions on that. And the what could happen is the last part of it, and this interface is particularly new because when I did this on January, the it was a little bit different. They added this column here on the left. Then what could happen, it you, it makes you ask a question of what should I do to change my variable, in this case tenure. You want to you want to make sure that your clients stay more. So what can I do to make them stay longer? So you can play with every one of those columns that are on the input of the story. You can fix something in particular, like uh, for example, you want to make some predictions that are related to senior citizens, so people of old age. So you want to, how can what can I do to affect my clients that are of older age? So like you can fix senior citizenship to yes, so it will try to predict your model for older people. And paperless billing, so it will be a billing like with email or something, and it will add half a month to the average for that particular group. One thing that is interesting, what is important on this is that every variable that is on the input, they are sorted by the correlations. It means that according to what the model learned from your data, it believes that modern age is one of the most important things that affects how much time your client is staying with you. So you can change that. And uh, this one column that I was working with is important. Actionable variables are variables that are things that you can change. You can take some action to change the outcome. For example, when you are working with your clients, you cannot change the client's region normally. Like you cannot force the client to move to another city. You cannot change the senior citizen. You cannot make your clients older or younger. But you can make changes to for example, device protection was a column that was related to an insurance in case that there is some power outage or something that uh, causes the device to malfunction, and you have a replacement program. So you can have in this case you had no, yes, and no internet service. So there was a classification where for people that don't use internet, they don't offer the service at all. But for those who have internet, you can add a premium insurance for them. So in case the modem failed, it will replace them. So in this case, what I am looking is that what could happen if I worked with the senior citizens that has internet with no device protection. So this is what the model believes will uh, will cause changes on the behavior of those clients. So And when you're working with what could happen, you will dig into this. It will go back and forth, changes variables until you see something that is more relevant, more insightful. It's not something that the application will do for you. You need to make some sense of it on top of what they will dig from the data. So uh, that's all I have to say for now. Do people have any questions? Hello?
Yes, no questions. No questions. I think everything was clear. Okay. Thank you, Carlos, for sharing your knowledge
Okay
with
then.
us.
So if there is no questions, I believe that's all I have to say for now. Thanks for coming by. And if you are interested into studying for this certification in particular, uh, we here will be always open to some helping with some difficulties and questions. And I believe that's all. Thank you.
Thank you, Carlos. Thank you for all for coming.